Hello, good afternoon, everyone. Am I audible?
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah. Now we had the group number 12 is to present now. Posture content test open drawing method. And
Yes, group number 12 is
yeah,
present.
if you're ready, group number 12, if you're ready with the presentation, you can start sharing your screen. Group number 12, Festus 49, 90, 64, 120, 71, 103. Yeah.
And can we start? Hello, am I audible?
Yeah, you are audible. Group number 12. You can share the slide. Start sharing the slide. Yeah.
Okay. So, good afternoon, everyone, respected men and my dear friends. My name is Moses Ripra, enrollment number 064. We're group number 12. Our group I got the topic on moisture content test by oven drying method and alcohol method. Begin with the introduction. There is moisture content test. It is also known as water content. Well, it is the quantity of water content in a material such as soil. It is denoted by the small w and it is usually expressed as percentage. Oven drying method. The aim or the purpose of doing this experiment is to determine the water content in soil. It is the simplest and most adapted method by the determination of the water content. Here is the apparatus required for doing this experiment. There is electric oven machine, then weighing machine with an accuracy of 0.04% of the weight of soil taken. An air container which is made of non-corrodable material with lid. Then at last, tones. Then for doing this experiment, this is a procedure. First, take a container that should be clean and dry with the lid. The W1 is nothing but the weight of the container. Then take the required of the wet soil in the container that take the weight of that soil. That will be considered as W2. Then place the container inside the oven by maintaining the temperature between 105 degrees Celsius to 110 degrees Celsius for 24 hours until the weight becomes constant. And for different soil, we have different timing and different temperature. We have 4 hours, and for soil like cell. And for the soil having high gypsum, the temperature should be at 80 degrees Celsius to avoid the loss of water of crystallization. And then after 24 hours, take out the soil from the oven and remove the container. Take the weight of that container along with the soil using the tones. Then the weight of that dry soil should be considered as W3. Here I have placed a simple picture for better understanding because one, then continue, and that should be kept at 105 degrees Celsius to 110 degrees Celsius for 24 hours. Then the soil after the soil is really dry out, that is W3. So with this, I conclude my part and I'd like to request our group member Prasanta Devarma to continue with the next presentation. Thank you.
Hello, everyone. Good afternoon. Myself, Prasanta Devarma, and my enrollment number is 120. From here, I'm taking forward the presentation. As my group member Moses has discussed the moisture content of soil by oven dry method, now I'm going to represent the calculation for the moisture content by oven dry method. To calculate the moisture content or water content of soil, we have the formula here. The water content W is equal to W2 minus W3 divided by W3 minus W1 into 100%.
What's the aim of the experiment? So basically, it's a rapid method of determining the moisture content. Though less accurate, but is the most suitable as a field test. This method shall not be used if the soil contains less proportions of clay, gypsum, calcareous matter, or organic matter. The apparatus which are required for the experiment are for the first we have the evaporating dish which should be of 10 to 15 centimeter in diameter. Second, pellet knife or steel spatula having a blade of 10 centimeter long and 2 centimeter wide. Third, talent or weighing machine. It should be for sufficient sensitivity to weigh the soil samples to accuracy of 0.4% of the mass of the soil taken for the test. Lastly, the methylated spirit or alcohol. Uh, Scroll down, please. The picture of the methylated spirit or alcohol has been added below. Have a look into this. Now I'm done with my part and look forward for Mr. Bibrajit to take over the rest of the presentation. Thank you.
Hello everyone, my name is Bibrajit Majumdar and my enrollment number is 103. I will be taking the procedure part. Clean the evaporating dish, dry and wet that is the W1. Take appropriate quantity of soil specimen is in evaporating dish with W2. Pour the methylated spirit over the soil at a rate of about 1 milliliter for every gram of soil taken so that the soil is well covered. Pour the methylated spirit well into the soil with the plate knife and break up any large lumps of soil. Place the evaporating dish on a surface which will not affected by heat and ignite the methylated spirit. Seed the soil constantly with a spatula or knife, taking care that none of the soil is lost. After the methylated spirit has burned away completely, allow the dish to cool and weight it with the contents W3. The next part will discuss the
Hello everyone, my name is Yongam Chandi, enroll ID 090. So last but not the least, here are the calculation. The percentage of water content shall be calculated as follows. W equals to W2 minus W3 divided by W3 minus W1 into 100%, where W stands for water content present, W1 stands for mass of this in gram, W2 stands for mass of this with dead soil in gram, and W3 stands for mass of this with by soil in gram. So here we would like to conclude our presentations, and I would like to thank you all for the time and attention today. Thank you so much, and I can see that our time is just about to up. So to finish, I would like to say thank you all once again.
Hello.
Yes, ma'am.
Yeah, all the members have presented.
Yes, ma'am. Yes, ma'am.
149, 90, 64, 100. Or maybe I got disconnected. Wait.
So, ma'am, so
Hello.
you can hear our
Your
presentation
voice
over.
is, yeah, your voice is not clear.
Okay, okay, okay. What about now, ma'am? Hello.
Hello.
Yeah, ma'am. Did you hear our presentation?
No, no, it's okay.
Oh, okay. Thank you, ma'am.
Group. This is group number 12. Okay, group number 12. Block meeting. You said that this thing, no, oven drying method you have discussed. So, what is the temperature range of drying the soil?
Hello.
Hello. What
Yes.
was the temperature range of your this drying the soil?
105 degrees Celsius to 110 degrees Celsius.
Yeah, and so which will take lesser time? If sandy soil, clay soil to dry?
Ma'am, sandy soil.
Yeah. Why? For how much hours you are keeping the soil in the oven?
24 hour.
Yeah. Okay, 24 hours. But when your soil is sandy, na, what happens is when your soil is sandy, your particles will be large and it will have larger pores. So that's why what will happen? It will dry fast. That means the moisture content will be this one evaporated. Okay, or the moisture will be removed from the soil in a very less hours. Like it can take from 4 to 6 hours. Okay, and if your soil is clay, you have to obviously keep for 24 hours. Why we keep for 24 hours? Because it is within the range, na? If your soil is too much clay, what will happen? Its particle size will be smaller, pores will be very small. What will happen? That may take 16 to maybe 24 hours, so maximum 24 hours. So we take the soil, whenever we oven dry the soil, we always keep it for 24 hours, because we don't know how much we don't know exactly that when it will get dried completely, na? So we keep for 24 hours. Okay, thank you, group number 12. Now we have group number 11. Group number 11, you can share your screen. You can start sharing your screen if you're there.
Ma'am,
Huh?
can you share the screen?
I have to share. Okay, group
Okay.
number 11.
Yes, ma'am.
Okay. Group number 11. We'll try to complete fast. Okay, we'll try. I'll share. Is it visible? Screen?
No, ma'am.
But here it is visible.
Yes, now it's visible.
Okay.
Ma'am, now it's blank.
Yeah. You can start.
Ma'am,
Hello. Yeah.
it's showing blank.
But here it is showing PowerPoint. This one, Sandbar
Um,
Method. Your my screen is not visible.
Now it's visible.
Okay.
Uh, Good afternoon, everyone. My enrollment number is 021 from Group 11. And next slide. The aim of our presentation is moisture content test on Sandbag method and radiation method. So the first part is Sandbag method. The apparatus required are sandbag, containers for tray, heating equipment, spatula, scoop, and small tools. Theory. Sandbag method is a simple method for the determination of water content. The method is rapid but not very accurate. Sandbag is a large open vessel containing sand filled to a depth of 3 cm or more. A soil sample is taken in a tray. The sample is scrambled and placed in a tray. A few pieces of white paper are also placed on the sample. The tray is weighed and mass of wet sample is obtained. The next slide will be presented by next member.
Hello. Good afternoon, ma'am. My name is Emily Sanglagichu, roll number 9. Here is the procedure for Sandbag method. The soil sample is crumbled and is placed loosely over a tray. The weight of the sample plus the tray is determined and recorded as M2. The weight of the tray alone is recorded as M1. The sandbag is placed over some form of heating equipment. The soil sample with the tray is placed over the sand contained in the sandbag. Special care must be taken to avoid heating up of the tray. The sample is stirred continuously in order to avoid burning of the soil. To get an indication of overheating, crumbles of paper can be added to the soil sample. Next slide. The sample can be checked whether it is completely dry by removing it from the heat and weighing the mass, after which the sample is again heated for 15 minutes and weighed. If both the mass remain same, that is a variation of 0.1 gram for fine grained soil, 0.5 gram for medium grained soil, and 5 gram for coarse grained soil is acceptable, it indicates that the soil is completely dry. After drying, the sample is allowed to cool and the weight of the dry soil is taken as M3. The procedure is repeated for 3 trials and the average value is taken. That's it for the procedure. Now I give time to the other member.
Good afternoon, everyone. I will be reading out the calculation and the precaution part. So, coming to the calculation, the percentage of water content shall be as follows. The water or moisture content will be equal to W percentage into W percentage, which is the water content percent, which will be equal to W2 minus W3 divided by W3 minus W1 into 100. W2 equals to mass of container with lid with dry soil in gram, and W3 is the mass of container with lid, and W1 is the mass of container with lid with wet soil in gram. Next slide, please. Ma'am, the precaution part. Precaution. Sandbag method employs high temperature that can affect the crystalline structure of the soil. Hence, it is not recommended for organic soils and soils with high gypsum content. Now I request the next member to proceed with the presentation.
Good afternoon, everyone. My enrollment number is 030. Here I will be explaining in brief about this Sandbar method. It is a quick
Hello.
method that is generally used when
Your
facility of
voice is
oven
not.
is nearby.
You're not audible. We can't hear you.
Hello, ma'am. Hear me now?
Hello.
Hello. Hello,
Hello.
ma'am.
If you're
Hello,
using
ma'am.
headphone, you remove your headphone.
Oh, ma'am, I'm not using.
Hello.
Hello.
Ma'am,
Can you hear me now, ma'am?
Who is presenting? We can
Ma'am,
hear him. I'm not able to hear why.
ma'am, can you hear me now, ma'am?
Okay, if others are able to hear, you can continue.
Here I'll be
But
explaining
just inform in the chat box when I have to, go to the next slide. Just write in the chat box because I'm not able to. You're not audible to me.
Here I'm going to share a brief explain on this
Which
Sandbar method.
is required.
It is a quick method that is generally used when facility of oven is not available. And if we don't have the oven, then we can use the stove method. So first container is placed over sandbar and heated on stove. And on the top of the sandbar, we place the soil in the container. And all the process to find the weight and the weight of the container is like oven trying method. The important thing of this method is that it is not used for organic soil and soil which contain high percentage of calcium, and we cannot control the temperature. The drawback of this method is that it has no control over temperature and it gives approximate result, hence generally not preferred. I give the time to our next member.
Hello, ma'am. Hello, ma'am. Can you hear me? Good afternoon, everyone. My name is Tepulvi Crow. My enrollment number is 045, and I'll be presenting on the topic radiation method. Since my friend has already explained about the Sandbar method, I'll be going to radiation method. It's a moisture content test on radiation method. Apparatus required are steel casings, emitters, detectors, radioactive material like cobalt-60. Theory about it. Radioactive isotopes, or it is also called as radioisotopes, radionuclide, or radioactive nuclide, are used for the determination of water content of soils. A device containing radioactive isotopes materials such as cobalt-60 is placed in a capsule and is then lowered in steel casing A, which is then placed in a borehole, as we can see in the figure in the next slide. The steel casing has a small opening on its one side through which rays can come out. A detector is placed inside steel casing B, which has an opening facing that in casing A. Now I give time to the next member to proceed.
Hello, ma'am. Um, in this radiation method, two steel casing are lowered in the ground where the content is to be determined. One of the casing consists of radioactive C60 and the other consists of the. When radioactive material is activated, it emits neutron. Neutrons are emitted by the radioactive metals. The hydrogen atoms in the water of the soil cause scattering of neutrons. As these neutrons strike with the hydrogen atoms, they lose energy. The loss of energy is proportional to the quantity of water present in soil. The detector is calibrated to give the water. I give the time to our next member.
Hello, ma'am. Ma'am, next slide. My name is Kolab Narzari, and my enrollment number is 040, and I'll be presenting procedure and precaution. The device containing a radioactive isotopes material such as cobalt-60 is placed in a capsule. It is then lowered in a steel casing placed in a borehole. The steel casing has a small opening on its side through which rays come out. A detector is placed inside another steel casing which also has an opening facing the first case. Next slide, please. Neurons are emitted by radioactive material. The water of soil causes loss of energy as a result of scattering of neutrons by hydrogen atoms. Energy is proportional to the quantity of water present in the soil. The detector is calibrated to give water content directly. Next slide, ma'am. The radiation method should be used problem ships in. Thank you, ma'am.
Am I sharing the screen? Our presentation is over. Yeah. Your presentation, you had this thing, radiation method, and your sandbag method. Now, this one, this radiation method, my screen is not visible now. Okay, whatever it is. So this radiation method, can it be used in the in situ condition? Oh. How can you determine the water content of a soil deposited in the in situ condition? When do we use? When can we use this radiation method? Book number 11. We can use this radiation method, right? We will use this radiation method to determine the in situ water content. Okay, we can use, because we are using here two steel casings, right? Containing what? Some will contain radioactive isotope, okay, and one detector also. These things, okay. So when in situ you can connect by determine by your this radiation method. Calcium carbide is not your one now. Okay. Okay, then no problem. This one was Sandbag method. Okay. I'm just going through your presentation. If it's okay or not. This both Sandbag method and your this one, the radiation method, both can be used on the field to determine the moisture content. Okay, then it's okay, okay. The Sandbag, just take it in a tray. Okay. Okay, thank you. Group number, we'll take some question later on this one, because all these three groups, that is your 12, 11 and 16, all the three groups are discussing about the moisture content of the soil, so your questions can be common. So like which method is best, like that. Okay, so group number 16, if you are ready with your calcium carbide method, torsion balance method, and your pygnometer method, you can start sharing your screen and present. Thank you, group number 11. Okay, group number 16. I was not audible or what?
Ma'am.
Huh? Hello?
No, no, ma'am, you're audible. Audible, you're audible.
Yeah,
Hello.
okay.
Ma'am.
Then you start presenting group number 16.
Ma'am, can you share our BBD, please?
Group number 16. No, wait. Group number 16. Group number 16, you have given me in a Word file. You have not given me PPT. Where is your presentation? Group number 16, I have not got your presentation. I think, got your Word file one you sent me before. If you have now your presentation, you send me or send in the group. Hello? Group number 16? Group number 16, roll number 91, 92, 100, 121, 121, roll number 61. Can you send me your presentation here in WhatsApp? Then I can share.
Ma'am.
Otherwise, you share your screen.
Ma'am.
Yeah, hello?
Yes, ma'am. Actually, we have lost that file. So, is it okay, like, yeah, if we do tomorrow or something like that?
Huh?
We have lost, actually, I've lost that file. So, like,
So now what do you do?
maybe I will remake it, and then is it okay, like, if we do in our next class?
Next class you're going to give. It will take time. No? Wait, I have one PDF. Not sorry, PDF. This one. You had sent one Word file, but I don't think it is okay. Only one you had given. Portion balance method. Calcium carbide method not completed. Your presentation is
No,
not
ma'am.
complete.
Actually, ma'am, we have sent a bit. I will share now with you that.
Huh? Other groups, how you lost your PPT? How other groups they don't have your file, or only one was making, or what the file? Everybody should have the group members PPT. What is this? Is anybody else this one ready with your presentation? If you want to give the presentation now, you can give. Group number 13, 14,
Yes, ma'am.
19, anyone? If
Ma'am,
you're
13.
group number
Ma'am, 13.
13,
Group
okay.
13.
Group number 13, if you want, you can present now today. Specific gravity of soil.
Ma'am, can you share the screen?
Yeah, wait. Group number 13. My screen is visible?
No, ma'am.
Hello. My screen is visible?
Now visible, ma'am.
Okay,
Yes, ma'am.
your voice is very low. Can you please increase your volume? Or if you're using a headphone, you can remove that and speak, I think. Then I
No,
think it should be audible.
good afternoon, everyone.
Yeah.
My name is Nyamarata. My enrollment number is row number 10. I'm going to start the presentation by group 13, and our topic is specific gravity of soil. Next slide, please. Introduction. Relative density or specific gravity is the ratio of the density mass of a unit volume of a substance to the density of a given reference material. Specific gravity of for liquid is nearly always measured with respect to water at its densest at 4 degrees Celsius or 39.2 degrees Fahrenheit. For gases, the reference is air at room temperature, 20 degrees Celsius or 68 degrees Fahrenheit. Its dimensionless quantity, the formula for specific gravity given that the reference substance is water, is the density of object divided by the density of water. Next slide. Specific gravity of soil. The specific gravity of soil and soil solid refers to the mass of solid in soil compared to the mass of water at same volume. The name specific it is a bit misleading since soil solids are made of so many different particles, each with their own separate gravity measurements. As such, the specific gravity of soil solids is actually an average of specific gravity of all included soil particles. In general, the specific gravity tends to fall between 2.65 and 2.80, with coarser soil generally having low specific gravities than finer soil. The formula for specific gravity is Gs equal to unit weight or density of soil by unit weight or density of water. Now I would like to pass the next slide to the other members.
Hello, ma'am. Hello. Good afternoon, ma'am. Hello.
Yeah, good afternoon. You're audible. You can start.
Hello.
You
Good
can
afternoon,
continue.
ma'am.
Yeah, continue.
Okay, ma'am. Good afternoon, everyone. As our group member already discussed, what is specific gravity of soil? Now I am going to discuss why does this test matter. Knowing the specific gravity of soil helps engineers understand how porous the soil is or how many voids it contains. It also indicates how saturated the soil is with water. Engineers use these measurements to perform important calculations that predict whether the soil at a site will be stable enough to support a structure and allow proper drainage. Ma'am, please, next slide. Next slide, please. Now I'm going to discuss the methods of specific gravity of soil. There are generally two methods. Here we will only discuss about the density bottle method. So number one, so there are two methods. Number one is density bottle method and number two is pycnometer method. So let's discuss about the density bottle method. This test is done to determine the specific gravity of fine-grained soil by density bottle method as per IS 2720 part 3 section 1. The specific gravity is the ratio of the weight in air of a given volume of a material at a standard temperature to the weight in air of an equal volume of distilled water at the same stated temperature. Now I request my group members to please continue slides.
Good afternoon, ma'am. My name is Sakidul Islam and my enrollment ID is 032.
Hello, ma'am.
Yeah, you're audible.
Ma'am, next slide.
Next slide. Okay.
Hello, ma'am. Hello.
You're audible. You can continue.
My name is Akidul Islam and my enrollment ID is 032. So I am going to discuss about the apparatus. What apparatus use in density bottle method. Number 1. Two density bottles of approximately 50 ml capacity along with stoppers. Number 2. Constant temperature water bath 27.0 plus 0.2 degrees Celsius. Number 3. Vacuum desiccator. Number 4. Oven capable of maintaining a temperature of 105 degrees Celsius to 110 degrees Celsius. Number 5. Weighting balance with an accuracy of 0.001 gram. And number 6. Spatula. And ma'am, next slide. Preparation of sample. The soil sample 50 gram should if necessary be ground to pass through a 2 IS sieve. A 5 to 10 gram subsample should be obtained and oven dried at a temperature of 105 degrees Celsius to 110 degrees Celsius. Thank you, ma'am. The next part will discuss by Deepu Rajbangshi.
Good afternoon, ma'am. Myself, Dipuraj Bongsi. My enrollment number is 035. I am going to discuss procedure part. Point number 1. The density bottle along with the stopper should be dried at a temperature of 105 to 110 degrees Celsius. Cool the desiccator and weight to the nearest 0.001 gram. Point number 2. The subsample which had been oven dried should be transferred to the density bottle directly from the desiccator in which it was cooled. The bottles and contents together with the stopper should be weighed to the nearest 0.001 gram. Cover the soil with air-free distilled water from the glass was bottle and leave for a period of 2 to 3 hours. For soaking, add water to fill the bottle to about half. Point number 4. Entrapped air can be removed by heating the density bottle on a water bath or a sand bath. Next slide, ma'am. Point number 5. Keep the bottle with the stopper in a vacuum desiccator for about 1 to 2 hours until there is no further loss of air. Point number 6. Gently stir the soil in the density bottle with a clean glass rod. Carefully wash off the adhering particles from the rod with some drops of distilled water and see that no more soil particles are lost. Point number 7. Repeat the process till no more air bubbles are observed in the soil water mixer. Point number 8. Observe the constant temperature in the bottle and record. Point number 9. Insert the stopper in the density bottle when wet.
Point number 10, now empty the bottle clean thoroughly and fill the density bottle with distilled water at the same temperature. Insert the stopper in the bottle, wipe dry from the outside and away. Point number 11, take at least 2 such observations for this sensor. Thank you, ma'am. Now,
Good afternoon, ma'am. I'm audible. Hello. Hello.
Yeah, your volume is very low. Your voice is coming very low.
Now it's audible, ma'am.
No, yeah, very low volume.
Hello.
Yeah, hello. Yeah, you start continue.
Myself Parthudim Sunwal and my enrollment ID is 051. Now I'm going to discuss the observation table. Here we have to take at least 3 soil samples to determine their specific gravity, and temperature in degrees Celsius, to weight of bottle W1 in gram, weight of bottle plus dry soil W2 in gram, weight of bottle plus soil plus water W3 in gram, weight of bottle plus water W4 in gram. Then next slide. Hello. Here calculation is given. Specific gravity equal W2 minus W1 minus W1 into minus W3 minus W2, result average gravity. Ma'am, next slide, please. Hello, ma'am, next slide. Conclusion, the specific gravity of the soil particles lie within the range of 2.65 to 2.85. Soils containing organic matter and porous particles may have specific gravity values below 2.0. Soils having heavy substance may have values above 3.0. That's all. Thank you, ma'am.
Okay, what do you hello? Hello, hello. Am I audible?
Yes,
yes,
ma'am.
ma'am.
Yeah, okay. In your presentation, actually, what is your specific gravity? What do you mean by specific gravity of any substance?
It is defined as the
Huh?
weight density or density of the substance by the weight density or density of the standard substance.
What is that standard substance?
It may be air or water or any solid.
Yeah, and what is the density of water?
It's 1,000.
Huh?
Hello.
Hello?
1,000 kilogram is the mass density of water is 1,000 kilogram per meter cube.
Yeah, I'm not yeah, audible. Can't hear properly. What is that? Your specific gravity of, sorry, your density of water?
And the mass density of water is 1,000 kilogram per meter cube.
Okay. Actually, what do you mean by specific gravity? That means what we can
Ma'am,
check from your
it is the relative
specific
density
gravity.
of
Why
any
do we
substance.
need to check that specific gravity?
Ma'am, actually, it is the relative density of any substance.
Hmm. That means how compact or how heavy it is, that no. Suppose in a given
Yes,
volume,
yes,
how much it is compacted or how much heavy is your substance, that we can check from our this one density,
yes, ma'am. Yes, ma'am. Yes, ma'am.
right? Because what happens, how whether it will float. Suppose you have dropped one substance in your water, because we are taking the reference of water. So when you drop the substance in your water, whether it will float, it will sink, that you can understand by your specific gravity, right?
Yes, ma'am.
Okay. Okay, thank you. Group number 16. Wait.
13, ma'am.
Ma'am,
Yeah, sorry,
13.
sorry, sorry.
Group
13,
group
13.
number
Wait,
13.
group number 13, no? Okay. I'll share the WhatsApp video. What? I'll share the attendance link in your WhatsApp group. So for today, we'll next group, group number, next presentation, next last class. I think it will be your last class. So there will be group number 16 is going to present. Group number 16, 14, 19, and 20. Okay. So thank you for today. It's over. We'll end.